Hello everyone, this is the second part of the radicals section when we're going to be multiplying and dividing radicals and rationalizing the denominators. Okay, when we're multiplying radicals, there's really a couple steps we need to do. The first step is we break down the radicals, so that's where we're pulling our perfect groups, or pull your perfect groups after that, sorry. Multiply the whole numbers and pool the radicands together. I will show you what that means. And then pull perfect groups again just to make sure everything's simple. Alright, so we're going to stroll in a little bit here. I'm going to bring our steps up like so, and let's zoom in on this first one. Okay? So again, the first thing we're going to do is we're going to break down the radical. Now obviously 2 doesn't break down any further than that, so we get radical 2 times. But now 8, remember 8 is 4 and 2. 2's all done. But 4 breaks down as 2 and 2. So I've got radical 2, 2, and 2. So break down the radicands. Now, our next step is to pull the perfect groups. Now again, because I can't see the index of the radicals, they're assumed and we know them to be 2, so I'm looking for perfect pairs of 2. Well, in this first radical, I don't have that. So the second one, I do have a set, so I'm going to kick that out as a 2. Okay, scooch that out of there. Whoops. So, we are now going to have radical 2 times 2 radical 2. Okay, so then our next step is we're going to pool the radicals together. Now realize we're going to multiply whole numbers with whole numbers just like we normally would. So 1 times 2 is 2. And then we're going to pool the radicals. So again, I've got 2 2's here, so 2 and 2. And then our last step, again, pull perfect groups again. So again, I've got another pair here that's going to kick out. So 2 times 2 is 4. So my final answer for this one would be 4. Alright, so let's go over to the next question. Alright, so here we go. Question 2. Again, I apologize for the blurriness. I did take this from a worksheet. So again, radical 2, we break down the radical first. I can't do anything with radical 2. But radical 6 is 2 times 3. So 2 times 3. Alright, so we broke down the radicals. Pull the perfect groups. Well, again, index of the radicals, since I can't see them, are 2's. So nothing happening here, and nothing happening here. So we're going to multiply the whole numbers and pool the radicands. Now again, remember there are 1's hiding in front of this thing. So 1 times 1 is 1. And we're going to pool the radicals. So we have 2 2's. And we got a 3. Alright, so now let's pull our perfect groups. So we're going to kick that out as a 2. So 2 times 1 is 2, so we get 2 radical 3 as our answer. Alright, scooch over. Alright, so here we go. Start by breaking down the radicals. Now again, I know 25 is 5 times 5. So I get radical 5 times 5. Radical 3 I can't do anything with, so radical 3. Second step, pull the perfect groups. Index of the radicals are 2's, and I've got a pair here, so I'm going to kick that out. Now remember with this one that there's nothing under the radical, which means there's no radical left here. So this is 5 times radical 2, or radical 3, sorry. Now, we're going to multiply the whole numbers and pool the radicands. Now again, remember there's a 1 here. Whoops, let me make that look like a 1. So, whole numbers are whole numbers. 5 times 1 is 5. Now, we're going to tack on the radical. And then our last step, pull perfect groups again, but obviously with radical 3, there's nothing more to it. So, that is our answer. Alright, now dividing radicals is a little more involved. I'm going to start by breaking down the radicals just like we normally would. Pull perfect groups, reduce whole numbers to whole numbers and radicals with radicals, multiply the coefficients and pool. We're going to reduce again, and then rationalize the denominator if needed, and reduce one more time if needed. Again, we're trying to keep things under the radical as small as possible. That's why we have so many reductions. Alright, so here we go. Here's our first example, so I'm going to zoom in. And I'll bring our steps kind of over here. Okay, so here we go. First thing, let's break down the radicals. Now again, 8, 4 and 2. This is 2 times 2. Or as if you've seen our videos before, shortcut for 8 is 3 2's. All over radical 2. Okay, next step, pull perfect groups. Well, again, I get a perfect group here, so it's going to kick out of the radical as a 2. So I now have 2 radical 2 all over radical 2. Okay, now reduce whole number to whole number and radicals to radicals. And again, we're going to reduce regular numbers just like a normal fraction. Well, and again, 2 and 1, I really can't do much here. But the radicals I can reduce. But just remember, we don't intermix the 2. So that means there's no more radicals in this problem here. And the rest of these steps, as you're going to find, you're not going to use all of them all of the time because they're made just for when you have a lot of radicals. So for instance, multiply the coefficients and pool the radicals. Well, we can't. We're just left with 2 over 1 or just 2. Reduce. You can't. Rationalize the denominator. Well, that means there's a radical in the denominator to begin with, so we can't do that. And reduce one more time. Well, can't do that either. So we were done right here at step number 3. Okay, so like I said, a lot of steps, yes, but you're not going to be using them all the time. Okay, unless worst case scenario. Alright, so let's scooch this over. Let's look at question 2. And let me move my steps over here. Alright, so here we go. Step number 1, break down the radicands. Again, 10, 2, 5. So I have 2 radical 2 times 5 all over radical 5. Step 2, pull the perfect groups. Well, no perfect groups in the top, no perfect groups in the bottom. Reduce whole numbers to whole numbers and radicals to radicals. Well, whole numbers aren't reducing, but I can take out some radicals. So, there's nothing left in the bottom, and I just have radical 2 on the top now. So I have 2 radical 2 over 1, or just 2 rad 2. Now, multiply the coefficients and pool. Well, we don't have that here. Reduce, you can't. Rationalize the denominator. Well, there is no denominator. And reduce if needed one more time. No need to. So there it is. Okay. Alright, so let's scooch over to the last one. And let me move my steps. There we go. Alright, here we go. So let's start off. Break down the radicands. 21 radical. Now, we all know 15 is 3 times 5. 3 radical 5. Can't do anything with rad 5 on the bottom. Pull your perfect groups. Well, there aren't any. So reduce whole number to whole number and radicals to radicals. Well, whole numbers 21 and 3 I can reduce to 7 and 1. Okay, so that makes life a little easier. I can also cancel off a set of 5s. So after all that, I'm left with 7 radical 3 over 1, or just 7 radical 3. So now, multiplying coefficients and pool, no need to. Reduce, can't. Rationalize the denominator, not needed. And reduce, you can't. So there is that one. Okay. Alright. Now, here's where it gets more interesting. Okay? Now, those other ones, we didn't have to do very much in terms of rationalizing or anything like that. But here we will have to. Okay, so let me set ourselves up, and I'll show you what I mean. Alright, so here we go. Step number 1, break down the radical. Rad 7's got nothing. Rad 3's got nothing. So I can't do anything there. Pull perfect groups. Yeah, that ain't happening either. Reduce whole number to whole number and radical to radical. Can't. There's nothing there. Multiply the coefficients. Well, this really isn't a multiplication problem, so I can't do that either. Reduce. Can't. So now we're stuck. And now here's where step 6 comes in. Rationalizing the denominator. What we're basically going to do is we are going to create a perfect group on purpose to get rid of the radical in the denominator. Because one rule is you cannot have radicals in the denominator of a fraction. So we are going to multiply top and bottom by radical 3 because that's what's going to create a perfect group for me. Okay? So we're going to multiply these together.
I need you to go upstairs and get dressed, please.
So you get radical 21 all over.
Sarah today.
And rad 3 times rad 3 is regular 3. So now we don't have a radical in the denominator. And our last step is to reduce one more time if needed, but again, this is a regular number and this is a radical. We can't intermix and reduce those. So this right here is our final answer. Alright, so as you can see, it's getting a little trickier now. Alright, let me scooch this over a little bit and then we'll start on question 2. Alright, here we go. Whoops, there we go. Alright, here we go, folks. Step number 1, break down the radicals. Well, 6 is, as we know, 2 times 3, and radical 3 is just radical 3. Pull perfect groups. Well, we can't. There are no perfect groups. Reduce whole number to whole number and radical to radical. I got a set of radicals here that I can cancel. So that takes care of that, leaving me just radical 2 over 1, or just radical 2. Multiply the coefficients. Well, this isn't a multiplication problem, so I can't do that. Reduce. No, it's just radical 2. I can't reduce. Rationalize the denominator if needed, but there is no denominator, so I can't rationalize. And reduce one more time, but you can't. So there's that one. Pretty simple. Okay, now let's scooch this over. I'll drag this over here. Alright, here we go, folks. Alright, let's start. Now, when you see something, this big radical symbol here over a fraction, that just really means radical 5 over radical 2. Okay, so that's what that really means. Alright, so first things first. Break down the radicals. No, we can't with 5 and we can't with 2. Pull perfect groups. Well, we can't. Reduce whole number to whole number and radical to radical. That ain't happening either. Multiply the coefficients. Well, it's not a multiplication problem, so I don't do that. Reduce. Can't. Rationalize the denominator. Okay. I've got a radical in the denominator, so I've got to clear it. So to make my perfect group, I need one more set of 2's. Okay. So I'm going to multiply these. I'm going to get radical 10 all over 2. Okay. So then we reduce one more time if we can, but radical 10 over 2, we can't. So that's my answer. Alright, here's where it gets a lot more fun when we have a lot more involved here. Okay. So first thing I'm going to do is let's break down the radicals. Okay. So 8, I know, whoops, is 2 times 2 times 2. 3, radical 10, 2 times 5. Okay, 9, radical 12, 9. Now 12 we know to be 2 times 2 times 3. 6, radical 20 is 2 times 2 times 5, because 5 times 4 is 20. I'm going to have to scooch this over a little bit here. Okay. Now 24 is 8 and 3, and I know 8 is 2 2s, or 3 2s and a 3, and 25 is 5 and 5. And then the last one, 10 radical 3, 2 radical 2. Alright, next step, pull perfect groups. Alright, so here I can take out a 2.
Daddy, I want to.
Okay, so I'm going to take out the 2. So I get a 4 on the outside. Okay, so this goes away. So 4 radical 2. Now on the bottom I can't do anything with, so I'm going to keep it as 2 times 5. Okay, up here I could take out a set of 2's and times it with the 9 that's already there. So 18
Did you
radical
do
3.
all this stuff?
Kick this set of 2's out, and 2 times 6 is 12 radical 5. Okay, here's 2. So now we have 4 radical 2 times 3. Here's a perfect pair. That'll work out nice for us. It's a 5. So 25 perfectly, because that's a perfect group. And here I can't do anything with 2 radical 2. Okay, so now let's reduce whole number to whole number and radical to radical. Now remember, since we're multiplying fractions, I can reduce up and down and diagonally. So I'm going to start radical 2 and radical 2. Gone. Let's see. I can reduce this 2 over here and this 2 over here. They cancel. Okay, what else can I cancel? Well, let's do the whole numbers. Like here, I can make this gone, and this drops to 5. So this is gone. Now I can go diagonal here with this 5 and this 25. 5. And this cancels completely, except for the rad 3 left there. Okay. Now what else I can get? Well, I can get the 4. And I can get the 3. Okay. I can go 18 and 3. This drops to 6. This cancels. Okay. Alright. Let's see if there's anything else by the look of it. 4, we got a 3 and a 5 on the bottom, so it doesn't look like it. So now this is where this step comes in. We're going to multiply all this stuff together. Okay. 4 times 6 is 24, so we get 24. We pool the radicals. So I have a radical 3, a radical 3, and a radical 3. So 3, 3, 3. On the bottom, I have a 3 and a 5, so that's 15. And then we have...
That's not a 3.
But that's a 3. And then we have 5 times 5. Okay. Now let's reduce again if we can. Well, again, because sometimes you miss something. Okay, so again, I can, here, the whole numbers, I can take out a set of 3's. Make that an 8, a 5. Okay, I gotta scooch this down a little bit here. Running out of room. I love you too, honey. 8 radical 3 times 3 times 3. All over 5. Radical 5 times 5. Okay, now let's pull perfect groups. Okay, because obviously we've got perfect sets here. So let's kick that out.
That's blue.
Yeah, and this kicks out as a 5. So we now have 24 radical 3 all over 25. Oh. Now, from here, rationalize the denominator while there's no radical left, and reduce one more time if needed, and we can't. So as ugly as that thing was, that is our final answer. Oh.
This is gonna be big.
Yeah. Alright, start breaking down the radicals. 6 radical 2 times 3. 2 radical 8 is 3 2's. 9 radical 18 is 9 and 2, so 3 times 2.
Those are 2 3s.
Yeah. 4. Crap. Let's fix that. Okay, so 4 radical. Now 30 is 6 and 5, so 2 times 3 times 5.
Now that has to touch to that blue thing.
10 radical. Now 40 is 8 and 5, so 2 times 2 times 2 times 5. And this is 3 rad 7. Alright, so let's start by pulling perfect groups.
That is red.
Yeah. And take that out. 6 radical 2 times 3 all over 4 radical 2 times.
I want to see myself in the video.
Okay, in a little bit. 27 radical 2. And the bottom's got nothing. 2 times 3 times 5. Okay. Now here I can take out a set of 2's. So I'm going to have 20 radical 2 times 5 all over 3 rad 7. Alright, next let's try to reduce. Make this a little smaller. Well, 6 and 4. I can make this 3 and 2.
Why did you put the next here?
Because I reduced the numbers, I made them smaller. Okay, 3 and 3. So this 3 and this 3 completely cancel. Let's see, I can go 4 and 20. So this cancels. And this drops to 5. Now let's look for radicals we can get rid of. So I'm going to get rid of this and this. Nice. I can get rid of this and this. The 3's. The 5's on the diagonal. Okay. And I don't see anything else. So let's pull this all together. So we're going to multiply the regular numbers. So 27 times 5 is 135. Radical 2. On the bottom, we have a 2 and a radical 7. Okay. Now. Okay, so now we have a problem. We try to reduce now, we can't. But I still have a radical in the denominator, and I can't have that. So we got to create our perfect group to make this happen. So we're going to multiply by rad 7's. So
That doesn't look like a 7.
how about now?
Nope.
No? Alright, let me fix it then. How's that?
Good.
Alright. So now.
The 7 had to be like this.
Oh. So 135 radical 14. Because 2 times 7 is 14. Now this kicks out as a 7 all over 14 itself. And then try to reduce one more time if possible, but it's not going to happen. So there's that one. Alright, so now we're going to multiply complex numbers. So again, remember our rule that we're going to multiply whole numbers with whole numbers and radicals to radicals. Okay, but again, this is foiling. Just like when you remember way back when we had something like this. 3 plus x and 2 plus 2x. It's the same idea. We used to FOIL this out. So we get 6 plus 6x plus 2x plus 2x squared. I had to come down a little bit. I should have just zoomed out. Right? And then we combined our like terms. So we got 6 plus 8x plus 2x squared. We're going to apply the same idea to this. The only difference is now we have to worry about radicals. So here we go. 3 times 2 is 6. Now remember, 3 times 2 radical 3 is going to be 6 radical 3. Now remember, there's a 1 hiding here. So 1 radical 3 times 2 is 2 radical 3. And 1 radical 3 times 2 radical 3 is 2 radical 3 times 3.
Yeah, they said you could go in with that.
Okay.
They were,
So then let's pull our perfect groups. Here's our perfect group. Kicks out as a 3. So 6 plus 6 rad 3 plus 2 rad 3 plus 6. So now let's combine our like terms. So 6 plus 6 is 12. Now radicals, as long as the radicands are exactly the same, we can add the numbers in front. So that's going to be 8 radical 3. And you're all set. Alright, this one. Multiply front to back. Negative 8. Negative 2 times the negative 1 that's hiding here is positive 2 radical 2. Now there's a 1 hiding here, so 1 radical 3 times 4 is 4 radical 3. And 1 radical 3 times negative 1 radical 2 is negative 1 radical 2 times 3. Alright, so now let's pull our perfect groups. Oh, there aren't any. So let's piece this all back together. Radical 2 plus 4 radical 3 minus 1 radical 6. And technically, folks, we don't need the 1. So now let's try to combine our like pieces. Regular number, radical 2, radical 3, and radical 6. So since none of the radicals are exactly the same, and I don't have any other regular numbers to put together, this is your answer. Alright, a little bit harder, so let's try this one. I'm going to put the 1 in. So 1 radical 2 times 2 radical 2. 2 radical 2 times 2. 1 radical 2 times 3 rad 3. So we get 3 radical 2 times 3. Now 2 radical 3 times 2 radical 2. 4 radical 2 times 3. 2 radical 3 times 3 radical 3 is 6 radical 3 times 3. Okay, so now from here, let's pull our perfect groups. This will kick out as 2. So 4. Nothing here, nothing here. This will kick out as a 3. So this will be 3 radical 6 plus 4 radical 6 plus 18. Okay, now combine your like terms. 4 and 18 is 22. 3 rad 6 plus 4 rad 6 is 7 radical 6. And we're done. Alright, looking at the next one. Negative 3 times negative 3 is 9. Negative 3 times 4 radical 2 is negative 12 radical 2. 4 radical 2 times negative 3 is negative 12 radical 2. And 4 radical 2 times 4 radical 2 is 16 radical 2 times 2. Alright, so now let's put this together. Pull perfect group. 9 minus 12 radical 2 minus 12 radical 2 plus 32. Now combine our like terms. 9 plus 32 is 41. Negative 12 rad 2 minus 12 rad 2 is negative 24 radical 2. Alright, now here's where it really gets fun, if you're not having fun already. Now notice, this has a plus sign. Unlike all the other pieces we have seen thus far, we have not had a plus. Remember, plus and minus symbols group pieces together as one whole piece.
I'm gonna get off if you're left.
So, you can't just multiply by radical 2 and make everything go away. Oh no. We have to multiply by its opposite, 3 minus radical 2. Okay. Now in doing this, which means you now have to FOIL this out. So 2 times 3 is 6. Remember, there's a 1 hiding here. 2 times negative 1 radical 2 is negative 2 radical 2. Over. Now we FOIL this out. 3 times 3 is 9. 3 times negative radical 2 is negative 3 radical 2. Positive 1 radical 2 times 3 is positive 3 radical 2. Then 1 radical 2 times negative 1 radical 2 is negative 1 radical 2 times 2. Okay. Now, let's pull our perfect groups. I gotta shrink this a little bit here so we can fit everything. Alright, so 6 minus 2 radical 2 over, now I'm going to pull my perfect group here. This kicks out as a 2. 9 minus 3 radical 2 plus 3 radical 2 minus 2. Okay. Now on the bottom I got to combine my like terms. Okay. Minus 2 radical 2. Now 9 minus 2 is 7. And these cancel. And now we have to try to reduce. 6 over 7 minus 2 radical 2 all over 7. And I can't reduce any of these fractions, so there it is.
1,
Alright, look at this one.
2,
5 plus 2 radical 3 for its opposite.
4,
So how many more
Okay, because that would be the opposite of the minus component. Alright, let's distribute. We have 20
need 1. We need
plus
1 more.
4 times 2 radical 3 is 8 radical 3 over. Now I'm going to show you a shortcut. Now if you remember in the last one, the middle terms canceled off when we did our foiling. All you really need to do when the pieces are the same but opposite signs is multiply the firsts and the lasts. 5 times 5 is 25. Negative 2 times positive 2, thank you Bella, is negative 4 radical 3 times 3.
1.
Okay. Now let's pull our perfect groups. Top's got nothing, bottom's got a set of 3's. So I'm going to multiply these. So 20 plus 8 radical 3 over 25 minus 12.
Your sister needs a fork?
Combine 28 radical 3
What?
all over 13.
I'm
Now let's try to reduce. 20 over 13 plus
Daddy needs a
8
fork.
rad 3
Sissy needs a
over
fork.
13.
Get out the fork.
And can it reduce? The answer is no, so that's all she wrote. Alright, here's another practice problem for you, so I'll let you give this one a try, give you about a minute to run it, and then I will work the problem with you. Again, you can leave the video running, and I will chime back in when it's time. Alright, let's talk about this one. Now, this one obviously is a little different because we have two of these here. Okay? So let's start. We're going to multiply by the opposite. 4 minus radical 2. 4 minus radical 2. Alright, so let's distribute. 3 times 4 is 12. Remember, there's a 1 hiding here and a 1 hiding here. 3 times negative 1 is negative 3. Radical 2. On the underneath, negative 1 radical 2 times 4 is negative 4 radical 2. And negative 1 radical 2 times negative 1 radical 2 is positive 1 radical 2 times 2. Alright, on the bottom, 4 times 4 is 16. 1 radical 2 times negative 1 radical 2 is negative 1 radical 2 times 2. Alright, so now, from here, let's pull our perfect groups. It's going to kick out as a 2. That's going to kick out as a 2. So we get 12 minus 3 radical 2 minus 4 radical 2 plus 2 over 16 minus 2. Okay. Now, let's combine alike terms. So 12 plus 2 is 14. Negative 3 radical 2 minus 4 radical 2 is negative 7 radical 2 over, and this drops to 14. Alright, let's try to reduce. 14 over 14 minus 7 radical 2 over 14. Okay, reduce 14 over 14 is 1 minus, no, 7 over 14 is 1 radical 2 over 2. And there's that one. Alright, this one's a little bit trickier, so I'll let you try this one out. Let's see how you do. I'll give you about a minute. Alright, here we go. Let's look at this one. So, radical 2 plus radical 3. Radical 3. Okay? So let's multiply. Radical 2 times radical 2. 2 times 2. Radical 2 times radical 3 is radical 2 times 3, and we'll fix that later. Yes, I know it is 6, but we'll fix that later. Here, 2 times 3, and then radical 3 times radical 3 is radical 3 times 3. Over, on the underneath, radical 2 times 2 minus radical 3 times 3. Okay, so now let's start pull perfect groups. It kicks out as a 2. Plus, now I can't do anything with that, so we're going to leave it, make it radical 6 now. Radical 6. And this is 3. This kicks out 2. This is 3. Alright, so it's looking a little bit better. So now let's clean up the like terms. So 2 and 3. 2 and 3 gives me a 5. Now I'm going to add these radicals. So 1 radical 6 plus 1 radical 6 is 2 radical 6 all over negative 1. Now, us math people don't like negatives in the denominator, so I'm going to bring these upstairs. So let's separate 5 over negative 1 plus 2 radical 6 over negative 1. So what we're going to do is bring the negative upstairs. We're going to get negative 5 double negative minus 2 radical 6. Alright, there's that one. Alright, I'm going to let you try this one on your own. Let's see how you do. I'll give you about a minute, and then we'll talk about this one. Again, you can leave the video running. I'll just come back in when everything's ready to go. Alright, here we go, folks. Let's see what you... Now I got to do the opposite of this. But notice how we have this radical 8. Now I know that can be broken down. And we should always break things down. But if you didn't, that's okay. Plus, now I know 8 is 3 2's. Kick that out. So you're going to get 2 radical 2. So let's do the opposite. 2 minus 2 radical 2. Okay. Now we're going to distribute. So 3 times 2 is 6. Minus 6 radical 2 over 4. And minus 4 radical 2 times 2. Okay. Let's kick this out as a 2.
Rosalind.
6 minus 6 radical 2 all over 4 minus 8. I'm going to combine these. Minus 6 radical 2 all over negative 4. And now let's try to reduce. Negative 4
Come and eat.
minus 6 rad 2 over negative 4. Negative 4. Alright, now notice I can reduce this. So I can reduce it by 2, so negative 3 halves. Double negative here turns out to plus. So we have 3 radical 2 over 2. Alright, let's try this one. I'll give you about a minute, and then we'll talk about it. Alright, here we go. So let's start off here, parenthesis up. So 2 plus radical 2. 2 plus radical 2. So 2 times 2 is 4. 2 times radical 2, most of us know by now, is 2 radical 2. On the underneath, 2 times radical 3 is 2 radical 3. And rad 3 times rad 2 is 2 times 3. On the bottom, 2 times 2 is 4. Negative radical 2 times positive radical 2 is negative radical 2 times 2. Alright, let's pull our perfect groups. On the top, I've got nothing. 4 plus 2 radical 2 plus 2 radical 3 plus radical 6 over, now here it's going to kick out as a 2. So 4 minus 2. Or, to make my life easier, we all know that 4 minus 2 is 2. So 2. So now let's try to reduce. Okay, so 4 over 2 plus 2 radical 2 over 2 plus 2 radical 3 over 2 plus radical 6 over 2 and reduce to finish. 4 over 2 is 2. Radical 2 over 2 is 1, so just radical 2 plus radical 3. And here I can't do anything else. 6 over 2. And there's that. Alright, so hopefully you learned a lot. This was a lengthy video, so I apologize. So hopefully you learned a lot, and we'll see you in the next lesson.